Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all the members into our discussion for today. We are going to look at the concept of a Gaussian elimination method. This is one of the strategies which we are going to use in finding solutions for a system of equations. And these are going to be basically the values of non-variables of x, which are going to be used in a specific system of equations. Now, in a sense, we're going to use the concept of reducing augmented matrix to an echelon form. And this is going to be assisting us try to, of course, find or evaluate this system of equations which consist of known variables. Now, in a sense, I'm going to be considering this specific aspect of systems of equations which are going to be given as such. So given a system of equations, so we're going to consider a system of equations which can be given in terms of these specific variables, of course, the matrix of A, and of course, we are going to see how the results can be represented. So we're going to have an equation of the form A given as such, where A are going to be the specific element of this specific matrix, and we're going to have it in combination with these unknown variables given as such. So this is going to be constituting a range of values for these specific, of course, variables and these elements of the matrix A. So this is going to go on to a value of 1n x raised to the power of or x n given as such, which basically is going to be equivalent to the value of b1 given as such. So we can give the second row of this specific, of course, matrix using the various elements which can be given in terms of this specific order. So this is going to be constituting the elements of x and this non-variable of a given as such. And this is going to be given using that specific format. So this is going to be giving us a B2. So this equation can be given for a range of variables which are going to be given in terms of n1 x raised xn given as such. And this is going to be a, of course, this is going to be 2n. So this is going to be n2, which basically implies that we're going to have this one given in terms of a row, nth row, and the second column given as such. We shall have this one x raised to the power of course, so this is going to be 2 given as such, and this is going to be 2 given as such. So we shall have this one to a range of values which we are going to have a n x n given as such. And this is going to be going on to a value of b n given as such. So this is going to be constituting a system of equations which are going to be under consideration. Now, in a sense, we can represent this system of equation in the form of a matrix which can be given as the elements of A given as A 1 1, A 2, A 1 2 given as such. And these are going to be going on to a value of A 1 n given as such. So in this case, we can as well represent the second set of values for the second row given for 2, A21, A22 to a value of A2n given as such. And of course, we can represent this to the last, of course, form of this specific representation for the values of n2, and then we're going to have a value of n given as such. So this form of matrix can be represented by having these specific elements of A and their non-variables, which are going to be constituting the first one for x1, x2 to xn. And these are going to be giving us the result of b1, b2 to bn given as such. So this can form a general representation for the various range of values which we are going to be having for this particular set of values for the A, which is going to represent an n by n matrix. And we're going to have these specific coefficients which are going to represent known variables and the result of a B given as such. So as I've said, given such a kind of a system of linear equations, it can be represented in form of this particular set of values which we have given in terms of a matrix form. And as I've said, this is going to be forming a general set of values which can be represented as A x, which is equivalent to B, implying that this specific form of matrix can be expanded to give this particular form. As we can see that these particular values of particularly A can be given, or rather x can be given in terms of x1, x2 to a value of xn. And we can as well have this particular set of B given in terms of B1, B2, to a value of bn given as such. Now, from our previous discussion, we had said that we can give we can use an augmented form of such a particular nature of a b for us to find or try to reduce this specific matrix to an echelon form. And in this case, we're going to see that there is going to be a difference between this reducing this specific matrix to an echelon form. And of course, in our previous discussion, we talked about the concept of a row reduced matrix to echelon form, or a row reduced echelon form kind of a matrix. But the Gauss elimination method is going to be using this augmented form in order to form what we refer to as an echelon matrix. So in this case, I'm going to be using a specific example for us to achieve this in trying to look at a system of course, equations which are going to be consisting of this particular range of coefficients and the variables of x and of course the values for b, and try to see how we can use this Gauss elimination method using the augmented form in trying to achieve the solutions for those specific variables. Now we're going to consider the system of equations which I've given on the right side of the board. Now in this case, we're going to take the respective coefficients for such a kind of a system, and then we're going to be representing them as such. So we shall have this one as a n by n form of a matrix represented by the various coefficients of 1, 2, and 1. And then we shall have 2, 8, 7 given as such, and 2, 7, 9 given as such. So this form of a matrix is going to be given as a product of that one with the x1, x2, and x3. And this is going to be forming a result for the range of b's, which we have said is going to be 4, 20, and 23 given as such. So this is going to be forming a form of that specific kind of a matrix which we have said. And this can be given in terms of augmented form, which are going to be given in terms of this specific representation. So we're going to have this one given as a 1, 3, 2, 2, 8, 7, 1, 7, 9. And we can give this one in form of an augmented form for having the, of course, values for b for 4, 20, and 23 given as us. So we're going to perform some sequence of row, of course, elementary, row procedures which are going to be assisting us, or operations which are going to be assisting us in trying to reduce this one to an echelon form. And I'm going to form a series of course, operations which are going to assist us in trying to evaluate this specific set of values. So in this case, I've performed a series of operations which are going to be row, of course, a series of elementary row operations which are going to assist us in trying to reduce this specific aspect of the equation, and of course to echelon form. And as we had said, we are going to use this specific form which is going to be given in terms of a, b given as such. And this is going to be forming our augmented form, which we're going to reduce this specific matrix. Therefore, I've performed these specific operations, elementary row operations, which are going to consist of changing the row 2 by having a row 2 minus 3 row 1. So this is going to be assisting us try to reduce row 2 to a form which is going to be, of course, an echelon form. So this specific operation is going to be, of course, affecting this section for b, and therefore we're going to see that as we reduce this specific form to an echelon form up to this specific point, we're going to obtain a result of such a kind of an equation where the leading entries are going to be preceded by this kind of zeros, as we're going to see. And of course, we're going to have these final results, which is going to be having our specific matrix of A being given in terms of an echelon form. Now we're going to have to write this specific equation in terms of, or write this one in form of an equation. And this is going to be constituting values of x1 plus x2 plus x3. Which basically is going to be giving us a result of 4 as indicated for this specific section for B. So we're going also to have x2 plus x3 giving us the results for the second case for 4. And we shall have the last one given as x3, which is going to be giving us a result for 3 given as such. So using substitution, we're going to see that we can have the various range of results by doing a subsequent substitution for these specific values. And this is going to be giving us the specific values of these particular equations. Now, in a sense, we're going to see that these unknown variables are going to be given the coefficients for this specific section of the matrix, which we have reduced to echelon form. And therefore, we're going to have the first variable for x given in terms of, this specific coefficient for x given in terms of 1. So for the second one, we're going to have 2, the last one, and then we're going to have 2 given in that specific order. So that's going to be assisting us achieve the results which we are going to look for, particularly for the unknown variables of x. So in this case, we're going to have x1, x2, and x3 being given various, of course, values. So as we can see from this specific evaluation, then therefore it's going to be directed that we can have x3 given in terms of 3, which is going to be that specific value. So x1 is going to be having a value of 5, and the x2 is going to be having a value of a -2 given as such. And this is going to be forming solutions for the various forms of equations or unknown variables which we have been looking for using this specific type of Gauss' elimination method. Now, in our subsequent video, we're going to look at the Gauss-Jordan elimination method, which basically is going to be involving reducing a matrix to a row-reduced echelon form, unlike this one, which basically is just in form of echelon form. And we're going to see the difference between the two and how we can use those specific procedure for obtaining solutions of such a kind of a system of equations. So kindly check out description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for updates on our different uploads we do in math and sciences. So that is it for now, guys. In our next video.